Hello everyone, welcome back to my channel codeWithKhan. So if you are new to my channel, please subscribe to my channel. Let's see today's LeetCode problem 1009. Complement of base 10 integer. It is easy mark. Let's read the question. The complement of an integer is the integer you get when we flip the all zeros to 1 and all the ones to 0 in its binary representation. For example, the string 5, so the integer 5 is 101 in its binary representation and its complement is 010. So 1 is flipped to 0 and 0 is flipped to 1 and 1 is flipped to 0. So we got 010 as a complement of integer number 5, which is if we convert this into integer number, then it becomes 2. So given an integer n, we need to return its complement. So basically complement means, so whenever we have given integer n, so we will get its binary representation. So 5's binary representation is 101. So if you flip all the characters in this binary representation, so 1 becomes 0 and 0 becomes 1 and this 1 becomes 0. So if you flip all the characters in this binary representation and we convert this into integer, it becomes 2. So 5's complement is 2. Okay, and let's see the constants. Constants are n can be 10 to the power of 9. So if it is 10 to the power of 9, then how many bits are required to represent the n? So it requires log to the power of 10 to the power of 9, so which is approximately equals to 30. So 30 bits are required to represent 10 to the power of 9 integer number. Okay, so now let's see how we can solve this problem. So basically they have given integer n. So what we'll do is we'll convert this integer into binary representation using inbuilt method, which is integer to binary string. So then we will get a binary string, right? Let's see, binary is equals to integer dot to binary string of this n. So it gives us a binary number. So for example, if n is equals to 5, then we will be getting string binary as 101. So what we'll do is we'll iterate the string and we'll flip its characters. So basically we will take string result is equals to, initially it would be empty, and then we will be iterating the our binary string int I is equals to 0, I should be less than binary dot length, and then I plus plus. Okay, what we'll do, if binary dot char out of I is double equals to 0, then we'll append, or let's take it as a string builder so we can append it. Result dot append. If it is 0, then we'll append 1. In else scenario, we'll append 0. Got it? So like this we can flip all the characters in the next binary representation, and at the end we will be having a result is equals to 010 in 010 string. So what we'll do, we'll use another inbuilt method, which is to convert this binary string into integer, which is integer dot parseInt. So which will take the string result comma and the base, so it will convert it into a integer number. It will convert this binary string into the integer number and will directly return this integer number. So this is one approach using converting it to a binary string. So we'll be converting it to a binary string and we will be preparing the resultant string by flipping its characters. If you have 0, then we'll flipping it to 1, and if you have 1, then we'll flipping it to 0, and at final we are converting the resultant binary string into integer, and then we'll be returning that integer. Okay, and what is the time complexity for this one? So time complexity is going to be log of n. Why? Because like if any given integer n, it is going to contain only log n bits. Got it? That's why it would be log n times. Okay, let's see one more approach, another approach, right? Approach 2. So if you don't want to use these inbuilt methods like the parseInt and converting it to binary string and using this extra resultant string, So we can do let's observe something like we have used some a operation called XOR, right? So binary operations which is called XOR. So what XOR does actually, so when we have, let's take one example 1010. So if you we know what are the XOR means, like if you have 0 and 1, it gives 0 XOR 1 gives 1, 1 XOR 1 gives 0. So if we have same bits, then it will give 0, and if you have different bits, it will give us the 1. So using these things, we can flip the binary characters at a constant time, right? So if you see, we have 1010, and if you do XOR with the ones, all ones, so what it gives, so these are different, so it will give 1. This is same, it will give 0. These are different, it will give 1. And this is so if you observe these two strings, this is our input string, and we did XOR with all ones with the input string, and it is given 0 and 0 1. So 1010 we our input, and it gives 0 and 0. That means it flipped all characters, right? So this is the XOR capability. So if we use XOR with our input string, and we'll do XOR with all ones, right, of same length as our input string, then it will flip all the characters. So using this functionality, so we can simply convert our given integer input into our we can find its complement easily. So let's say how we can do that. So basically here we don't to do anything. We just need to build this mask thing. So we need to just build this as a mask. So we just need to find how many characters are there in this input string, and we will be building a new mask of length of the same length. Okay, so what we'll do is how we can find how many binary numbers are there, binary digits are there. So we can simply do while, so let's take a new number maybe. So let's take it as a temp variable. Temp is equals to n, while temp is greater than 0. So what I will do, so I will so I have already mentioned in my previous videos, if you want to add a placeholder digit, so what we have to do, we need to do a left shift for that operation. So initially I will take int mask as 0 integer. So I will do mask is equals to mask left shift with 1. So what it will do, it will create a placeholder with a 0, and then what we have to do, we have to add one placeholder because we have one digit, right? I will add the mask with one digit. I will do OR. So by doing OR, we can append the a binary digit. So it will become 1 now. Okay, and then we need to delete the last digit from the temp. So temp right shift 1. So by doing that, so how many we'll iterate through each character in the input binary string, and we'll be adding one the same number of ones to the resultant mask. Okay, so at final we'll be building a mask of length the same input characters. So if we have 1010, that is 4 characters in the input, so we'll be building a mask as 4 ones. So at final we'll just return our input string integer is n XOR our mask is mask. So it will give us the flipped binary string, and it would be converting it into integer. So we will get the complement of the given input integer n. Got it? And what is its time complexity? And its time complexity is also same as log of n. Why? We are only iterating the binary length. Got it? And there is no space complexity. We are not using any extra space. These are only big of 1. Got it? Now let's try to code for this. Let's take our variables. Int mask is equals to 0, where we will building the mask. And let's take a temp variable. Temp is equals to it would be n. So now here let's state our base condition. If n is double equals to 0, then we will straightforward return 1, otherwise we'll find the mask. So what we'll do, we'll iterate till temp is greater than 0, and then we need to do the operations to build the mask. So I will do in the single operation. So what we need to do, first we need to add a placeholder by doing left shift with 1, and then we need to append the character 1 to the mask thing. So and then we need to remove one character from the temp variable. So I will be doing right shift with 1, and then once that is done, we'll be having the we will be building the mask variable. So once that is done, we'll just need to simply return an XOR mask. That's it. Now let's try to run this code. It is accepted. Now let's try to submit. Yeah, it is accepted. If you like my content, do like, share and subscribe. Thank you.